Question 2 of 9B says determine the general solution for the values of theta for which the identity is not valid. Write your answer as one single statement. We'll start with A over B. So if we have a fraction A over B, in order for A over B to be valid, B cannot be equal to 0. So we have to look at positions where our denominator is equal to 0. Let's start with this tan to theta, of which we can rewrite as sine to theta and cos to theta. So for basically both of them are in the denominator, so both of them cannot be equal to 0. So let's look at a position where our sine of 2 theta is equals to 0. Our sine graph usually looks like this, going all the way to 360, but we can see here that we have bounded our we have decreased our period, and we can only go up to 180. So basically, we can see here that um, every our reference zero in this case would be 0, right? And we can see every 90 degrees we encounter 0 again, so that's going to be 0. Okay, and therefore we can just rewrite this as 90k, and k is an element of integer. We see every 90 degrees we get that 0 back. So another one we have is cos of 2 theta, right? Our theta graph usually looks like this, where again we go from 0 to 360, but because of this 2, we know that we have bounded it and we only go through to 180. It will now cut at 45, so that means that theta will be 0 at 45, and this will then repeat itself after every 90 degrees, because here we will have 135. So every 90 degrees that happens, so there is then our general solution for theta. Then what we want to look at is our 10 over here. Now this 10 can be expressed as sine theta over cos theta, where the cos is the only one that's going to be in our denominator. So if we look at our cos graph being equals to 0, let's look at our graph. Oh, sorry, that's not how it looks. It looks like this. So then for our 0, we'll start here at 90 and will repeat itself every 90 or every, because this then will be 180. So that 0 is going to then repeat itself every 90 degrees. So our general solution for that one would be that cos of uh, theta is, again, it's going to the front and to the back. So we can do a plus minus 90 plus, because of the period, our period is 360, k 360, where k is an element of all integer. Then the last thing we'll look at is this one over here, which is 10. 1 minus 10 squared theta is equals to 0. And we can change that to say 10 squared theta is equals to 1. Okay, then we can square root on both sides, get the reference angle. So that would be 10 of plus minus 1, right? So both negatives and positive will do for this. And our reference angle for this would be 45, because if you look at our angle, right, minus plus 45, we'll get negative or positive 1 at 45 and minus 45. So therefore our theta would be equals to negative plus minus 45 plus 180, as 180 is the period of our graph. K, where again K is an element of all integers. If we look at all the solutions that we came up with, which is this one here, that one there, and this one here, we will see that they are all with reference to the 45 degrees. So each and every one of these it like includes 45, right? Or in this case also uh it's just the growth of 45. It's the 45, 90. All of them are in within our 45 ranges. So for our single solution, we'll write that theta is equals to 45 degrees multiplied by k, where k again is an element of all integers. And whenever we change k is equals to 0, then all of the solutions that we have come up with that it cannot be equal to will then be represented here.